Hello everyone, I am Anandavali. Welcome to this new video from Guidance Education channel.
In this video, we will discuss Fajan's rule. Before we go into the details of this topic, we will first recall what we have already learned. We have already learned that no compound in the universe is totally covalent or totally ionic. What does it mean? It means covalent compounds have partial ionic character and ionic compounds have some partial covalent character. We have already discussed in the previous video polarization of covalent compounds, that is, the partial ionic character of covalent compounds. Please click the I button in order to watch that video if you have not already watched that. In this video, we will discuss partial covalent character of ionic compounds. You know what is an ionic compound? Let us take the example of an ionic compound with minimum 2 atoms. In ionic compounds, there is a minimum of one cation and one anion.
We have already discussed how atoms become cations and anions. The cation is smaller and the anion is bigger.
Okay, if you take the example of sodium chloride, sodium chloride, sodium is the positively charged ion and chlorine remains as a chloride ion with a negative charge. Here, one electron is transferred from sodium to chlorine. So, sodium becomes positively charged ion, that is cation, and chlorine becomes the negatively charged ion, which is the anion. In order to understand the partial covalent character of ionic compounds, we have to understand three terms: polarizing, polarizable, and polarization. Polarizing means the capacity to polarize the anion. Cation has the property of polarizing and the anion is polarizable. By polarization, we mean distortion of the electron cloud.
Let us suppose this is the cation of the ionic compound with a certain number of positive charges in it. In the diagram, I have shown only one positive charge. I mean the total positive charge it possesses. And this is the anion having the number of negative charges. Here also I am showing only one negative charge. I mean the total number of negative charges on it. Due to the influence of the cation, the electrons of the anion will have a tendency to move towards the positive charge or the cation. As a result of the pull of the cation, the electron cloud of the anion will get distorted. That is, some of the electrons of the anion will be present on the side of the anion nearer the cation.
This distortion of this electron cloud is what you call polarization. As a result of this end of the anion will develop a delta negative charge and this end will develop a delta positive charge.
This distortion of the electron cloud of the anion is due to the polarizability of the anion.
So it is as if these shifted electrons are shared by these two atoms. So there is a sharing of electrons. In which bond electrons are shared between the participating atoms, that is in covalent bond. So here a partial covalent character is developed. So this ionic compound has developed partial covalent character. Let me repeat, this ionic compound has partial covalent character. This is what we call covalent character of ionic compounds. Please note that this covalent character is due to the polarization of the electron cloud of the anion due to the cation.
This is quite different from the reason for the ionic nature of covalent compounds. Please note the difference. In covalent compounds, it is the electronegativity of the anion which causes polarization of the whole molecule. One end of the molecule develops positive charge and the other end of the molecule develops negative charge. Coming back to our topic in this video,
Fajan's rule discusses the conditions or the factors which decide the extent of polarization or covalent character of the ionic compound. Three rules are discussed in your textbook. We will just see that. First one, size of the cation and the anion. Smaller the size of the cation and larger the size of the anion, greater is the covalent character. That is, in an ionic compound, if the cation is very small and the anion is very big, then the covalent character will be more. If you are comparing two ionic compounds and in one ionic compound the cation is small and anion is comparatively larger, then that compound will show more covalent character. That is, polarization will be more in that compound. That is the meaning. I hope it is clear. Second one, it states that greater the charge on the cation, greater the covalent character. That is,
the cation in the ionic compound may bear, depending upon its type, one charge, two charge, or three charges, and so on.
greater the positive charge, greater will be the covalent character. Now third one, for cations of same size and same charge of cation means number of charge. Transition metals are more polarizing than alkali and alkaline earth metals. Alkali metals belong to first group and alkaline earth metals belong to second group.
You know, in the periodic table, transition metals are from group 3 to 12. That is the D block elements.
What does this mean? Let us suppose there are two compounds. In one of the compounds, the cation is transition metal, and another compound, the cation belongs to alkaline earth metals. We are not referring to the anion. One compound has the transition metal as the cation and another compound has alkaline metal as the cation. Their sizes are same. The charge on the cation also is the same. Then the compound with the transition metal has more polarizing ability. That compound will have more covalent character than the compound having alkaline earth metal. Again, there may be a compound with transition metal as the cation and another compound with alkali metal, that is first group, as the cation. In that case also, the compound with transition metal will have more polarizing character. That is, the covalent character of a compound having transition metal will have more covalent character than the compound having alkali metal or alkaline earth metal as the cation. What is the other condition? Their charges should be the same. The size of the cations should be the same. So in short, we may say the comparative size of the cation and the anion and the charge on the cation are factors which decide the covalent character or the extent of the covalent character of an ionic compound. Normally, The extent of polarization is represented as percent covalent character. I hope I have made it clear. If you think the video is useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and press the bell button and all button for notification of more videos like this.
Thank you very much.
Bye for the present. Take care.